at some of the diagnostic capability that is built into our S7 controllers native out the box. So these are functions that exist in the 1200 and the 1500 range of PLCs. So we'll have a look at using this in conjunction with TIA Portal, which is our engineering framework, and using TIA Portal to get some helpful diagnostics for us, both for initial commissioning and for maintenance once our system is up and running, deployed in live production. So for the TIA Portal, we have an add-on, which is called ProDiag. Now what ProDiag allows us to do is create alarms inside of the PLC code itself, automatically using TIA Portal. So we'll have a look at that as well. And then lastly, we'll have a look at one of our new Simatic apps. Now this is called Notifier, and what this will allow us to do is start to push notifications to smartwatches, smartphones, when we have a fault with any of our control systems. So it's a system that can link into a number of controllers and start to generate push notifications to intelligent devices. Now the nice thing about this app is we can run it on the edge, we can run it in the cloud, or we can run it as a local instance that we look after ourselves. So we'll jump into TIA Portal now. And we have it running down here. So the first thing I'd like to show you is TIA Portal running without any project opened at all. So I'd like to show you some of the abilities that TIA Portal has for doing online scans and online diagnostics. So this would be very useful, for example, if we were a service engineer or we worked in the maintenance department of a building and we were sent to a breakdown. If we maybe didn't have the original project or we weren't sure what the controller was that we were starting to work with, we can use these online access tools. So when I have no project open in TIA, it is the first option in the project tree in the top left-hand corner. Now you'll see that it shows us all the network interfaces in our system, and if we have legacy equipment for Profibus, we would also be able to see that in here as well. So we've got a nice little indication as to which is our active interface. So you can see that I've got connection to field level controllers in my LM adapter here. And you can see that it's done a scan for us. So we can just update this scan, and devices are going to start reporting information back to us at a MAC address level. So the nice thing about this is we can have a look at our controller, which is just here, and we can drop it down, and straight away you can see that even without having any project loaded inside TIA Portal, we can start to do some diagnostics on this particular controller. So if we're looking online in Diagnostics, which is a very powerful tool, we can slide across to the middle of the screen. And now straight away we can see exactly what this type of controller is. We can have a part number for it. And this is very useful here as well, the version of TIA Portal that this was programmed in. Because we do have a mechanism where we can upload the project from the controller. So if we did turn up at site or we were working as a maintenance engineer and we didn't have the project, we'd have a fighting chance of pulling it back out of the controller. So underneath it, we can see that if whoever created this project in the first instance used intelligent naming, we'll get the information down here. And we even have the serial number and part number at the top of the screen. So if there was a requirement for this part to be returned or this part to be replaced, we both have those pieces of information there available to us as well. Now we can also have a look at the diagnostic buffer. So if we do have a known fault in our controller, we can scroll through and we can find what was tripping us up without actually having to go and obtain a project for this PLC. So that's just a very quick overview of some of the functionality we can achieve without even having a project open. So what I'll do now is I'll create as a new project, or I'll open one that I have on my desktop. And you'll see that the online access functionality stays, but we now have our name of our project, OC2, at the top. So we currently have a blank project, but for ease of engineering, I have some objects in my library that I'm going to pull and drag into my project here. So we're going to bring in an operator interface, and we are going to bring in the open controller device itself. So I'll drag and drop those into the project. and we can now have a look at how this has been created for us. So I now want to link together my controller to my operator panel, because we're going to use the operator panel to have a look at some of the diagnostics that can be reported to us over a standard HMI connection. So we now have a HMI connection established between our controller and our PLC. And if we have a quick look at the operator interface, we can see that we have some nice screens that have been pre-generated for us. So it's worth noting that the library object that I just opened and pulled in for this screen is available on our Siemens industry support site. This is something that we can download and we can start to use in our own projects. Now, the nice thing about the TIA panels is we have a number of controls that are baked in at the firmware level that allow you to give the operator some nice visualization and nice diagnostics of the status of the controller without having to engineer any intricate or fancy controls into your system. So you'll see what we have here is an alarm control, and this is one entire self-contained object that we simply drag and drop in from our panel on the right hand side. So there is no additional requirement for engineering with this option. We've also got a nice diagnostics tab or a diagnostics control. So we can see here that any information about the controllers in our project are going to be automatically, programmatically reported back to us into this screen. So we'll just double check the connections that are installed here. We'll just remove that one because we do not need to. But this HMI connection is now what is going to give us all the intelligent diagnostics from the controller over that field bus. So what I'll do is I will start to simulate my panel, because unfortunately I don't have one with me right now. And that will start to compile in the background there. And we can see that that has now appeared for us on the screen. So we've got a healthy tick to indicate that we have a connection to our controller because it's sat next to me. But unfortunately, we don't currently have the project deployed, which is in my TIA portal. So we're just going to do an online. We're going to do an extended download to device. And we're going to make sure that we select the correct controller and the correct port. So I want to download this guy on the X2 interface. So while that's downloading, I've just got another project open on my other screen, which has a scalant switch included in it as well. So what we'd like to do with this scalant switch is show you some of the functionality for network monitoring as well that's built into these controllers. So I'll just pull this guy into this project as well. So if we join him up to our Profinet network, we should be able to right click on here and go into our device configuration, and we should be able to go in our topology view and join this port up to this port here. So utilizing the topology view, we can tell the controller how the point-to-point wiring is achieved in our system. So if we do have any breakdowns in the cabling, we can instantly see where the connections have been problematic for us. And this information will ripple across a number of the different platforms that we are going to look at. So what I'd also like to show you is in the settings of the controller itself. If I quickly zoom in and have a look at system diagnostics, it's interesting to note that we have this tick box to activate system diagnostics for this device, but it is not something that you can turn on or off. So all the diagnostics for this controller are built in at the firmware level. So we're no longer having to write handlers for doing things like triggering alarm messages when I lose a comms module or when I lose a piece of I/O. All of this is baked down deep at the firmware level. So a lot of these intelligent alarm messages and intelligent diagnostics that are generated for us need to be symbolic. So what I mean by that is if we use the identification and maintenance option, we can start to give our controller and our elements in our project sensible plant designations and sensible location identifiers. because these will then be used in our diagnostic messages. So to give the person that's been called to the breakdown a sort of a fighting chance of determining where this fault is. So for example, we could have a name of a machine cabinet or a name of a line, whatever the requirement is for this particular system. So I've also got the web server enabled for us to have a look at, because a lot of this intelligent reporting will be fed straight through to our web server. And further down, we've also enabled the OPC UA to allow us to communicate with external systems. So now that I've got everything I need in my project, we'll just do another download. Let me just right click and download to device, hardware and software. And maybe we'll just give it a quick compile as well, and a thing that may have changed. So we have an issue with a lack of an OPC server certificate. So we will quickly generate one for ourselves. And let's try again with a compile. And then let's download that to the controller. So I'm connected to the X2 interface. We'll have another go at downloading to them. And there we go. We can see our controller is now responding. So we shall go to load. And hopefully our new controller system will be downloaded to the PLC. So it's worth noting that I do have a small controller sat next to me. Obviously it's unfortunate that you can't see it, but it will allow me to trigger some system faults. So what we're going to do is have a look at some of the faults that are generated by hardware diagnostics and how they are reported to us as the end user of the system. So I'd like to have a look at how it would be reported if you were to be physically in the panel looking at the front of the 1500 PLC. And I would like to have a look at how it would be reported inside the web server as well as inside TIA portal. So if we finish this, we should be able to finish loading the rest of the program. And once that is done, we should be able to go online. So if I click my controller here and click the Go Online button, anytime that we are online in TIA portal, we have these orange bars that indicate this at the top. So when it comes to diagnostics, straight away you can see a nice graphical representation of the health state of our system. So for example, if we start by looking at the project tree, we can see that we are online to our controller. The tick here is indicating that we have no faults and we're healthy. And these green orbs are indicating that what I have in my project is matching to what I have in my controller. In other words, my online and my offline configuration match. So straight away, some valuable tools to determine the health status of the controller and to determine whether we have a matching project in our online-offline scenario. So what does happen when we introduce a fault? So for example, I'm going to introduce a hardware fault on the edge of my controller by removing the server module. So this is basically the terminating plate at the end of the rail. So you can see in the project tree, we've now got a light on our controller indicating that we are no longer in run. We have the spanner over the controller showing that we're demanding maintenance because we have some errors. And we can see in our device tree that we have an issue here with our controller. So we can always have a look one level deeper. So you'll see in this view, we have 3 tabs: topology, network, and view. In our network view, we get an overview of all our devices, but in the device view, we can go one level deeper and have a look. So we can get to that in one of 2 ways. We can either click the tab, or we can double click on our controller here. So you can see here that I've gone into a bit more of a graphical representation of my PLC. And straight away we can see an indication on the rail as to what is causing us this problem. So unfortunately I don't have any other I/O modules with me, but if we had I/O modules on the rail that were reporting a fault, this would be a nice graphical way to get a clear indication as to what is causing you a problem. So for example, if we had a module that had failed, or we had the wrong color base fitted, or it was incorrect firmware, we'd get a nice little indication of what the fault is there. We can then double click on it and we get taken to the diagnostics for that particular module. So if I go to channel diagnostics or diagnostic status, we can see that this device is not reachable, and we can see down here that there is a hardware component removed or missing. So it's a nice indication on what the problem is, and we even have some help text down here that can give us an indication of how that we can remedy this fault. So all of this text is built in at firmware level. There's no additional sort of programming that we've had to achieve. You saw earlier that tick box is ticked by default and we cannot turn it off. So a nice function from there. We can also use the online and diagnostics option in the project tree underneath the controller itself. So if we double click in here, we can straight away have a look at the status of the diagnostic buffer of this controller. So we can see here that we've got a nice little bit of information to tell us we're now missing components. So if we see here, has one or more errors, we can also click this little button when we can take ourselves to where that error is occurring. So that is an error that is triggered from a hardware fault. What about an error that may be triggered by an issue in our network? So if we go back into our topology view at the top here, if you recall, this is the view that physically shows us how the system is wired. We can straight away here see that we don't have any problems. So the green cable is indicating that we're happy with this configuration. So if I was to disconnect my switch from my open controller next to me, we will see a brand new fault is being introduced here. So straight away, we got a nice visualization as to where the error has occurred. So again, if a maintenance colleague was called out to a breakdown, you can see here a pretty strict visualization as to where the cabling error has occurred. And again, if we were to look at the diagnostic buffer of this controller, it would be reported to us as a issue with the status of the device. So we can see here that we have a lost neighbor partner, so we cannot see the device that's in our project via that topology. So a nice and easy mechanism for having a look at that. Now we can also have a look at the bottom of the screen where we have an alarm display. So later on we can come back to generating some program alarms and we can have a look at them visually in the bottom of the screen. So that's a very simple mechanism for working around the TIA portal and having a look at the different areas that we can diagnose faults. So the next thing I'd like to show you is the faceplate on the front of a physical open controller, a physical hardware PLC. Now I appreciate I can't show you the front of a physical PLC right now. So I thought the next best thing is I could show you the mimic plate that a software controller offers you, because what we see on here is exactly the same as what you'd see on the little screen on the front of a S7 1500 PLC. So on this screen, we have a few different options that give us indications and overviews of the status of our system. So if I have a quick look at this, so if I make this a bit smaller so we can zoom in, move up here. The first tab that's of interest to us is this screen here, Diagnostics. And if we hit here, from the screen, we can look at the diagnostic buffer and we can look at the alarms. So again, this is great for someone that gets called to a breakdown that doesn't even have a programming laptop with them. So if the person that engineered the control system has utilized the features such as identifying the location of parts, we can start to have a look in our alarm screen and we can see what the issues are that are occurring. So we can see here that we have a hardware configuration error. And if we delve one level deeper into that, we can see hardware configuration error, missing server module. So we can see that we've now got a problem that's prohibiting us putting our controller into run. So similar to our maintenance task, if we got called to this breakdown, we would now know straight away where our problem is occurring. So the same applies for stations falling off the bus, and the same applies for I/O modules disappearing out of the system. They will all be reported as a nice little alarm on here. Now you'll see above that we also have our issue being reported for our missing network connection. So again here that we can see that we have a problem on our Profinet port and we can't find the partner that has been described to us in the TIA portal project. So that's a look at some of the alarms inside this screen. But there is also an overview of the status of the system by clicking on or scrolling along to this devices tab. So this gives us a nice little mimic of what is on the local rack, or if we have got a large field bus, this could be a Profibus as well. We can see a status of the items on the system. So obviously in my rack, I only had my PLC and my server module terminating the end of the rail, but we can see here that the server module is straight away defective in some way, shape or form. And if we go into here, we can see that the module status is not reachable. Now, if you scroll down, the nice thing here as well is we have the part number on the front screen. So again, if maintenance got called out, found out that the thing had been damaged for some reason, we could start to write down the part number and get on the phone to see who has another one of those available or pull one straight out of stores. You can even see that when it was online, it's pulled the serial number out of that module as well. So we get a nice little error message as well. So it's worth noting that this system is completely multilingual. So if you are shipping some systems abroad, this will all be generated for you in the language of the end user's choice. Now, if I was to look at the pumping station, we can also get a status of the controller, whether they are happy or not. So the controller is obviously in fault because we've got a couple of issues with our I/O and we've got an issue with our end module. So that's a really quick overview of the hardware diagnostics that are baked in and how they appear on our screen. So the last thing I wanted to show you for the hardware diagnostics is how it appears in our web server. So if we know the IP address of our PLC, we can attempt to hit it by typing the correct IP address in. Or alternatively, we can use the inbuilt connection of our controller. Click Advanced and we can continue. So again, the web server is a feature that is built in at the firmware level. This is just a tick box that we enable in the PLC configuration, and this is something that is turned off by default for security reasons. So once we've enabled it, we can connect. Out of the box, it's heavily restricted, so we can either open up to everyone in TIA or we can create individual logins. So if I have another go at my login, we can see here that on our very first page, we have got a nice overview of the status of our controller. So this would be another option for someone that's called to a breakdown. They would be able to access the web server if it's enabled on the IP address of the PLC. If the IP address of the PLC is not known, this is something that can be found again using this front legend plate mimic. So again, on the right hand side, we can see the version of TIA portal that this has been programmed in. So the bits that are interested to us is obviously diagnostics and the buffer as well. So if we look at the diagnostic buffer, we can see information about the status of the controller. So all those error messages that we've come across earlier, so our hardware component missing or removed is being displayed as an event in there. We can also have a look at the status of our modules. So again, we can go into the controller and again, we can straight away see that our server module is offline. If we hit details on it, we can get a nice little error message at the bottom regarding how that fault has occurred. So again, this is no extra engineering required. This is all baked in deep at the firmware level. Now, if we do have alarms generated for these faults, we can start to have a look in the alarms. So again, faults for the alarm system are automatically generated down here. Now, the last thing we'd like to draw attention to is the topology as well. So earlier on, we discussed the behavior of having a topology set in the project. So if I reconnect my system up, we should hopefully get an indication of the system. And there we go. So now we can see that my connection is happy. I'm now connected between my P1 of my controller and my P5 of my system. So if we had a large bus in here with a lot of drives, a lot of HMIs, a lot of operator interfaces, if we did have a breakdown in any of our network comms, this would be a great place to come and have a look for some indication. So we'll minimize that, and the last place we'll come have a look is our simulated comfort panel. So if you recall, we fired this up in the first instance, and we should now be able to have a look at those screens that are baked in. So obviously this is a blank project, hence why we've not got any information on it, but we do have the diagnostics screen, and we do also have the messages screen being shown on here. So here you can see our alarm messages are being generated as we saw them on the controller. So we won't dwell too much on the alarms and diagnostics in here because it's a similar method or a similar bit of information to what we saw inside our web server. So what we'll have a look at now is we'll have a look at generating some alarm messages programmatically using our ProDiag offering. So if we just clear all our faults on our controller so that we've got it back in a happy state, I will pop the server module back on the side of it. And once that is done, we can have a look at doing some ProDiag engineering. So again, for the ease of demonstration, I'm going to use the library concept. And what we're going to do is pretend that we have got some sensors that are feeding us, not sensors, we've got some 24 volt dry contact inputs coming from things like safety systems and airflow sensors. So if I have a look on my right hand side of the screen in my libraries, I have got myself a machine sensors tag table. And if we just drag this guy across to the left, we can pop him into tag tables. And also to go with that, I have got myself a watch table just so we can monitor what is occurring with our tags. So if I just open this up, machine sensors, we can see that what we have here is some fictitious inputs. So you'll have to forgive the fact that I've been using memory areas as opposed to input areas. I just don't have any I/O to sort of demonstrate this. So if we imagine that this is some inputs, some discrete inputs into our control system. So we have an air pressure, a water pressure coming back from some flow. We have our guards, our e-stops, and if the machine is currently in a safe state. Now, in a normal operation, we may start to engineer the alarms inside of the operator panel. So with the Siemens equipment, it's quite common with the older kit to use things like marker words and to manually type the alarm text in. So what we'd like to show with doing things like ProDiag is giving our tags symbolic names that are intelligent and mean something to us and mean something to an end user, but also utilizing systems where we can write comments. So a lot of people will comment their code anyway, but why don't we start to use things like this for our alarm texts? We've already done it once, so we might as well do it again. So what I'm going to do is create myself a ProDiag block. Now we can do this in a couple of ways. Probably the most simplistic is in this supervision column, right click and go add new supervision. So you will see this dotted all around TIA. And what that means is anything that you can right click on and find this option, you can turn into a alarm programmatically. Now I'm going to do it the other way, which is go into your project tree and hit add new block in your PLC code. So over here, you will see that in the programming languages, one of the options is for a ProDiag block. So I'm just going to type in machine alarms and then hit the enter button. So we can now see that I've got myself a machine alarms block down here, which is been handled by ProDiag. If I now go up to the top here and I right click on here and go to add new supervision, we can see at the bottom the area has changed into a section which has some configuration for me. And if I quickly zoom in again, we'll now see that this particular piece of input, as we imagine it to be, has now got a little symbol on it to tell me that this is being monitored actively by ProDiag. So if we lose this bottom area, it's nested under properties. I've lost it. And if we bring that back up, it's under properties, and then we have this tab called supervision. So we can start to give our supervisions names on the left-hand side. So maybe I can call this air pressure low supervision. And then in the main area where we start to configure it, we have a number of different options. So the top one is the type of error message this is. So there's a number of different error messages depending on machine states, and these can be chosen to match whatever the type of error is in your system. So for example, if we're looking at a guard status, or if we're looking at an item falling off a belt, or a task that an operator needs to do, we can choose one of these different supervisions. And then ProDiag is going to categorize the alarms for us when we are visualizing this later on in our operation. Underneath, we can then say our condition. So quite simply, are we a rising edge or are we a falling edge? And then we can also define conditions. So what we're saying is I can have up to 3 other Boolean values from my PLC code that have to be true in order for this alarm to show. So maybe if, for the example of something falling off a conveyor belt, we have to say that the conveyor motor contactor is pulled in. We have to say that we have movement on the conveyor encoder. And we also have to have a signal where a box has been fed. So we can make a situation like that where our alarms only come high if there's certain conditions that are already met inside of the system. Now at the bottom, we can choose a category and we can customize these. And these mix in with the alarm categories on the HMI. So we can start to customize whether these need a manual acknowledgement or whether they will disappear themselves when they've become remedied in the control system. So at the bottom, we can choose the ProDiag FB this is a part of. So what we're going to look at is nesting different alarms inside different ProDiag function blocks. So we can also create new ones in here, and we can choose them on the fly from this section. So I've already created mine earlier on. Now the very nice feature of ProDiag is using the values inside the PLC code to automatically generate your alarm. And this will hopefully now make sense why I've got these nice comments here written next to my code. Because if we go down, you will see that the alarm text is going to come up as the PLC name, the ProDiag function block name, so I've called it machine alarms, and then the tag comment. So we're going to get a nice, simple looking alarm with the data that's already in the controller. And this is highly customizable as well, which is a great feature. So the last thing I'll show you before we move on to there is we can also have custom text of fields down the bottom here. So when we click this button here, we can start to customize what is actually appearing in that alarm message. So you'll see here all the different options that we can bring in. So if we had categorized our alarm, is it an interlock? What is the name of the tag that we're monitoring? All of these items can simply be dragged and dropped into this area here to customize and give us a very nice alarm message programmatically. So we'll just delete that quickly for now. And then we'll have a look at downloading this to the controller. So if I now recompile, it'll compile anything that's changed. And then we can do a download here. So the thing to note with this is we've not had to power cycle our operator panel. It is still running for us down in the corner here. So if we quickly put our PLC back into run. We should be good to go. So if we have a look at our watch table, if we click play on this, we can see our air pressure low, and then if we force this to be high, we should hopefully now get an indication on our panel here. So we can see here, pumping station 2. This is my message that's been taken, which is the name of my PLC. Machine alarms is the name of my ProDiag function block, and low air pressure detected is the comment of my tag. So a nice and simple, attractive error message that's been very easily generated for us. So we'll minimize this guy out of the way again, and we will just go through and we'll finish off adding all of those as a supervision. So add new supervision, rising edge, add new supervision, rising edge. And we can do a download. And the PLC is not even changing state, so we've not lost our PLC out of run. We can go in here and let's force our simulated airflow and water flow, and let's force our defects in our guard circuit and a defect in our or safe stop condition. And now we should be able to come back in here and we can see without having to restart the PLC and without having to restart the HMI, we've now straight away got these nice error messages appearing on our alarms control. And the beauty of doing the alarming inside the PLC is this ripple through to all the other mechanisms which we looked at earlier on. So for example, if I was to have a look in my web server again, so if we bring this back up, you can see here that the maintenance guy that doesn't have a programming laptop can have a look at the web server, and all these alarms have rippled through. And the maintenance guy could also have a look at the front faceplate of the PLC itself. And again, we can see that all our lovely alarm texts have been brought through to this screen. So pumping station 2, machine alarms, safe stop active, clear machine alarms. So again, a very nice and simplistic way to achieve alarms programmatically without too much engineering effort. And because TIA is multilingual, we can look at the project text, export this and give it to the translator, and then we've done our alarms in many languages just by utilizing the comments that are inside of the tag table. So I'll quickly show you doing that as well, not necessarily for I/O, but also doing ProDiag alarming through function blocks that we are going to recycle inside our PLC code. So what I'll do in the first place is just tidy up our code a little bit. I'll make as a group for ProDiag, and I'll just pop our ProDiag organization block and our machine block in there. So if we go back into our library, I've got myself a simple block called tank control, because what our pumping station is doing is controlling a couple of tanks. So if we come in here, we have got some very basic logic. If our tank level is lower than 5, then we've got a low level. And if our tank level is over 95, then we are about to spill. And this is giving us some outputs from this block to indicate whether this is a low level or a high level. So what we can do is we can use the interface of any block, and we can start to make these values ProDiag alarms as well. So for example, we can again use the comments. So we can say low level alarm active and high level alarm active. And in a similar way that we did it before, we just right click on here and we go add new supervision, and we right click on here and we go add new supervision. So when we come back out, we can see that we have down the bottom the same options that we were used to before, and we can go and say I want a rising edge of that and I want a rising edge of this. And if we scroll further down, we can have a look at the alarm text. So between ProDiag in function blocks and ProDiag in tag tables, there are two separate structures of template formatting. Because what you can now start to do is if you have nested function blocks, so maybe I have 6 tanks per unit and I've got 4 units, I could have 6 tank control function blocks inside another function block for unit control, and we can start to do things like instance path. So this would allow me to generate an alarm message that used the hierarchy of the PLC code to show the operator or the maintenance member of staff where to go to sort of remedy this fault. So I like using the ProDiag function block name, the name of the call of the function block, the parameter that's effective, and the parameter comment. So that may be a little bit long for our little panel, so we can just use the comment from our parameter. So that's all we need to do to set up the supervisions inside a function block. So now what we do is every time we would call our standardized piece of code by dragging and drop it in here, we would then use the name of the instance as our name here. So this isn't best practice for programming. I would just like to do this purely to demonstrate ProDiag. There's other ways to achieve this. Now at the bottom, we want to separate our ProDiag alarms. So I don't want to put it into my machine alarms. So I'm going to say put it into my tank alarms. And now we go back to our library because we need some analog input sensors for our tanks. So I have some tank level sensors to put in my tank table, and I have some tank level sensors to put in my watch table just so we can force these values. So I will quickly pop in a couple more tanks controls. So we can have tank 1, we can have tank 2, and we can have tank 3. Now that we have those, we need to feed in some values. So we'll come back to our simulated analog input sensors, which are down here. And we have tank level 1, we have tank level 2, and we have tank level 3. Now if we give that a compile, so if we give our PLC code a compile and a download, we should now be able to monitor this block. So we can see our output's high, but this is purely logic based. So we want to see in our panel whether we have error messages. So we can see here that we have, I added my 2 and 3 to the wrong alarm section. So we can see here that we have tank alarm, which is the name of my instance data block. Unfortunately, I added the other 2 to the wrong one. We have tank 1 and we have a low level alarm active. So that is updated straight away. Now, because I've added it to the wrong one, it is nice and simple to move these around. What you can do is you can come into your ProDiag alarms, and if you double click on any one of them, you will then straight away get these 2 tabs, these 2 options. So you have the supervisions of just the tags alone, which we looked at first. And then you can have a look at the supervisions of the function blocks. So in an ideal world, I'd want to be removing these guys and putting them in the other one. So the last thing I'd like to really quickly show you, because I've almost run out of time, is Simatic Notifier. Now using Simatic Notifier, what we can do is we can start to have a look at sending alarms to our smartphones. So in my example, I've got it running on premise. And if we have a look here, we can see that Simatic Notifier is fully configured through a web browser. And now the way this works is we have a similar setup with a project tree. And on the left-hand side, we have user management. So inside the user management, we have different levels of staff. So we can have maintenance, we could have shift manager, we could have machine operator. And then on the right-hand side, we can start to filter the different types of classes that these people would be able to see. Now we need to add some smart devices as well. So there is a app for this on the Apple App Store, and there is a smartphone app, sorry, a smartwatch app on the Android Watch platform. So once we've installed these on our device, we will be given a unique code when we first fire it up, and this is given to us here. So I've added my iPhone. This is the code the iPhone has given me, and this is the role for myself. So maybe if I was the shop floor manager, I'd be getting some slightly different notifications. We then need to look down into tags, and especially into connections. So for ease, I've used OPC UA, but we do have the S7 Classic protocol for 300s and 400s. And we have the S7 Plus protocol for connecting to things like our 1200s and our 1500s. So once we've engineered the details of where our connection is going to be, so we can have multiple devices, we would start to engineer some tags that are going to be read out of it. So you'll see here my familiar symbols for my sensors that are out in the machine. We can give it an acquisition speed, And at the bottom, every time we select a particular tag, we can start to give it a notification text that corresponds to it. So we can do this conditionally. So if it's Boolean logic, it can be rising and falling, but we can also monitor analog values, so we can do conditionals greater than, less than, equals to. These sort of things are also available to us as well. So once we download this by clicking up here, we do a full download and we can start and stop the runtime. Then it would be a case of having a look on the smartphone. So what I'm going to try and do is share my screen with you off my mobile phone. So if I go to share screen, we can hopefully see what is occurring. So we can now see my broadcasting off my iPhone screen. And if I go back to my home screen, you can see I have the Siemens Notifier app here. So if I just reconnect myself to the server and move this away, we can see that I've just hit myself with a large amount of alarms because we've got a lot of alarm states active in our controller. So we can go into any single one of these alarms and have a look. So you can see down the bottom there, I have got the safe stop state. And a nice feature of this is I can accept the alarm as well. So what that means is if we had 16 different people using this app, then anyone else would then get a notification to say that Nick Stewart has accepted that particular alarm. So what that means is all the other colleagues that are in the shop floor will see a message saying the machine is in a safe state, but Nick Stewart is on his way to remedy this, so we don't need multiple people to have a look at this for us. Now we can also have a look back in TIA, so I appreciate you can't see it, but if I trigger some different alarms and I go back to my home screen, we should be able to see that we get a nice push notification on our main screen when any of these conditions come true. So I will just turn these alarms off for now in my controller, and I will modify these to 0, and then I will modify this to 1. So you can now see a notification at the top of the screen, and we can click on that, and I've now got my new alarm message ready for someone to go and fix that issue. So at this point, I'd like to say thank you for your time and open the session up to if there are any questions.